Here is the first page of the practice test. I went ahead and did number 1. Let me just point out that on numbers 1 and 2, the things you have to be aware of, you have to say, okay, this is absolute value. Absolute value always has 2 cases. That's true up here. That's true here. Absolute value, when I'm doing anything algebraic with it, I'm always going to set up 2 cases. The next thing I have to realize is these are equations. Okay? So absolute value equations is what I have. Those are the ones where I do sometimes have to be careful to check my answers to make sure that I don't have any extraneous solutions. The time you have to be really careful is if you have an x outside the absolute value. We don't have that on either one of these. So I'm not going to have any extraneous solutions here. But these are the types of problems where you could have extraneous solutions, and you have to think about that. Okay, so I did the first one. I set up my 2 cases. One looks just like this, x minus 2 equals 7, without the absolute value symbols. The other one looks like that, except that the 7's negative. X minus 2 equals negative 7. So here we go. X minus 2 equals 7. X minus 2 equals negative 7. I solve both of them, and I get 2 answers, and they're both my answers. Same thing over here. I'm going to say 3x minus 3 equals 15. And I'm also going to say 3x minus 3 equals negative 15. And I'm going to solve both of these. Adding 3 to both sides. And I get x is 6 over here. And over here, I get x is negative 4. Okay, it wouldn't hurt to plug those in and check them, but I tell you right now, they're both going to work. And I know that because I don't have that x outside the absolute value I have to worry about. All right, now, the difference between numbers 1 and 2 and 3 and 4 is the less than, greater than. These are inequalities. Inequalities, when I set up my 2 cases, and I still do have to set up 2 cases, but I'm going to have to change 2 things. I change, for one side looks just like this looks like. In other words, it looks just like the original without the absolute value symbols. The other side looks like that, but not only is 24 going to be negative, but I'm also going to turn around this inequality symbol. So I have 6x plus 6 is greater than or equal to negative 24. Another thing here is whether it's an and or an or. Because of the original symbol up there, because that's less than, it's less than, so this is and. So now I get to solve both sides. These are the ones where if, like when I'm dividing both sides by 6, if that had been a negative 6, I would have to turn around my symbol, turn around this symbol. It's not a negative 6, so I don't have to do that. And 6x greater than or equal to negative 30.
Do you have to write the and?
Yes, you do have to write the and.
Will you count ones off?
Yes. You have to write the and, or you have to change it to an expression with an and. That's the one where you can rewrite it where the x is between the 2 numbers. If you change it like that, the and is implied. I can change this to, remember where you do it in the same order as the number line? Mm-hmm. You put the smaller number on the left, the bigger number on the right, and you make everything point to the left. And that's the same thing. Those two say the same thing. I'm okay with this. I'm okay with that. The thing I like about this is the solution looks just like the graph. The graph is going to be 2 numbers on either side, closed in circles because of the or equal to, and then it's shaded between. And is always shaded between. Always, always. All right. Next one, it says greater than 15, so this is an or. Set up my 2 cases. One looks just like it did there. Or the other one, I'm going to turn around the inequality symbol, and I'm going to change the 15 to a negative 15. And then I get to solve. 5x is greater than 10. X is greater than 2, or 5x is less than negative 20. X is less than negative 4. So I've got a 2, I've got a negative 4. An OR graph is always split. So it's going to go in opposite directions from the center. Go out to the sides. So here's my solution. X is greater than 2 or x is less than negative 4. This with an OR cannot be written together like that.
Okay.
Just like the graph is not together. The graph is separate. You can't write it together. All right, number 5, identify the domain and range. Domain is the x values. So I've got 0, 1, 3, and negative 1. I like to write them in order. Then then identify the range. That's the y values. 2, 0, negative 2, 1. So negative 2, 0, 1, 2. Is that a function? That's a yes. The reason it's a function is because I don't have something like 0, 5 later. Remember, if you have the same x with a different y, that would not be a function. Like if I had 3, negative 4, because I already have 3, negative 2, if I had 3, negative 4, the whole thing would not be a function now. Thank goodness I don't have that.
Will it be anywhere, what was it, where you're talking about different, like it was 1 to 1?
1 to 1 is if all of them are unique. And basically, if nothing repeats, then on either the y's or the x's, that's 1 to 1.
That was 1 to 1?
This one is 1 to 1, yes.
Are you going to ask that?
I don't think so. Okay, vertical line test. The vertical line test, I have to be able to draw a vertical line anywhere I want to, anywhere on the graph, and never cross it twice. So, like, this is my vertical line. I have to be able to put this anywhere on the graph, and it'll always only cross the graph once. That's true here. No matter where I move that line, it's only crossing the graph one time. Okay, so that's a yes. It is not true here, because if I put it right here, it crosses twice. Okay, my vertical line, it doesn't cross twice here, doesn't cross twice here, but if it crosses twice anywhere, and it does right here, then that's not a function. So this is not a function. And I'm going to write not a function to be perfectly clear.
For 7, though, it looks like it's not a function like on the last loop because it's like on the same.
Yeah, but it doesn't actually, this is a curve, it never actually gets vertical. It looks like it's getting close to vertical, but curves like this never actually get vertical. They're just changing by so little you can barely tell. In other words, it's always moving over, it's just by little bitty bits. Good question.